Hey folks, welcome out there. Hey, for many of you, this is election day. And some of you, a lot of you students actually have the days off because it being election day, and your schools are used for precincts for voting and such. But some of you were in school, so there's some math problems coming up here in just a little bit, all right? But we want to welcome everybody. We're glad you've chosen to join us at this hour of the evening. It's starting to get dark a lot earlier, so you come inside. And now today was beautiful outside anyway. At least here in East Tennessee, we've had a great day. That number, by the way, go ahead and start planning on using it this show, all right? 844-686-2378. Send us some math problems. Let's work some things out together. We would love to have some chances to work some problems with you live on the air and solve some of your many worries out there, okay? But in the meantime, let's look at problem of the day, and you give us a call, all right? And as I said, today is an election day for many locations. It is locally here in East Tennessee. If 4,500 voters turn out and represent 20% of the eligible voters in a district, how many are eligible to vote? That is a big question. Many times we hear how many people turned out. We heard that is a certain percentage of the voter population. But we wonder, how many were they actually there? How many voters could actually have been there? Sometimes the news will mention that. A lot of times they just give us those two statistics. So we're going to show you how do we figure out how many were actually eligible to vote with this hypothetical situation. So let's take a look at it. Today is an election day, as we said, and we have many districts having it. And we've got a 4,500 voters turning out and representing 20% of the eligible voters. We've already mentioned that in district. Whew. How many are eligible to vote? And we had some folks who were already jumping on that thing in Facebook. We had some folks, Steve, way to go. Margie, also, I believe we had a little bit coming in from Mark also today. So some of y'all gotten back in on the saddle, getting in there and give us some nice answers and such. But we're going to see what it actually is, all right? So we're starting out with a small number here. This could maybe be a mid-sized town or whatever, but let's see where we're going. Again, I think I like my little method here, all right? And I like this is the way most of our teachers teach percentages and work with it, and especially in a situation like this, we're trying to find things that are not just 20% of a number, all right, which is not what we're looking at. We're looking for the number that is 20% of. Makes it a little bit tougher. So let's use that form that says part over the base equals, we'll say, percent over 100, all right? So when we're looking at this problem, what we're thinking about is, what do we know and what are we looking for, okay? Simple, straightforward. We've got two numbers that need to go somewhere here. We know percent goes over 100. All right, so let's go right there from the very beginning. We'll put that 20 over 100. And you know what I'm thinking? I'm thinking maybe we got to figure out which one's part, which one's the base. Do we know where we started from? No, we're going to take this 4,500 voters from a big pool, all right, a much larger pool. This represents 20%. So guess what? We put 20 over the 100. Let's do the same thing here. Let's put that 4,500, because basically it's the part. 20 out of 100, that's the part. And this is 4,500 out of question mark. We'll call it X. We can call it N, whatever you want to use, okay? Now, what are we going to do with this mess? We're going to do what we do with all great proportions. You know my favorite thing to do? Cross multiply. In fact, you guys enjoy doing it out there too, I'm pretty sure, because we get a lot of folks who take us up on this. So let's go ahead and do that. Let's cross multiply. Let's take that 20 and X together, and we'll just jam it right there. Makes it easy. And we're going to do the same thing here. And that's going to give us, my goodness, a 45 and a lot of zeros. How about 4 of them? Now, folks, we're not there yet, okay? We've still got to go a little bit to get to the final answer here. So let's pull it right up here. So I'm going to about to run out of room on this page here. So we got 20x equaling 450,000. And we're going to figure out what this x, this is what the number of eligible voters would be, all right? And we're going to do what? We're going to divide. And simple, going back to, a lot of times you always use that algebra stuff. I do. I like it because it gives our students and others a chance to see it, and when they start using it over and over, it doesn't become quite so foreign. It's not so difficult. But still, the idea is you multiply two numbers and you divide by the third number, okay? That's really what's going on in the proportions. So if you're thinking about it from the arithmetic, say, I learned how to just numbers with multiplying and dividing, that's fine. You understand where it's coming from. But this just helps keep us in line, what we do first, what we do second, and then we come to the right answer. So let's speak it through here. Let's do it. Divide both sides by 20. Remember, we always divide the left. We got to do the right. And I'm taking chances here. I think it's going to be 22,500. Let's see what we actually come up with. Calculator always is nice just to make sure, especially all those zeros running through there. Just got to be careful with them. We're going to lose one of them in the final answer. Yeah, we got a lot more. Let me start over again on that. Sorry about that. We'd really have a mess if I'd used that one. Oh, my goodness. Oh, my goodness. Oh, it's not Monday either, is it? Let's divide by 20. That's much better. And here we go. Did I get it? Oh, I did at least get the mental math right. Okay, so let's see what happened here. First of all, we lost the 0 there, as I said, and then we're going to divide 2 into those things. And 2 divided into 45, basically it's 22.5. So we have 22, and we have a 5, and then we have 2 more zeros to go along with it. So that is our number of voters. Now, you know, in big cities, obviously, it's going to be a lot larger. This looks like about a midtown area, and not everybody, you know, quote unquote, is registered, so we're not everybody eligible to vote. We wish you would. Speaking of which, before I leave today, all you who are going to be ready to vote or haven't voted yet, get out and do that if you have an election going on in your area of town. I know here we close down the polls at 8, so some of you can watch Mathline and then head on out. So anyway, there we have our problem of the day. Thanks for tuning in, by the way, folks, and hanging with us there. It is Election Day, like I said, which is an important day in our town and everywhere else you live when it's stuff that impacts you and where you are close to home. So get out and vote if you haven't done already. And let's see what we've got going here. I have a few little problems here I want to look at. So let's take a look at a couple of fraction problems here. How about this? And it says simplify to the lowest terms. You say, well, Ernie, what does lowest terms mean? We're going to reduce it all the way down. Now, I put these two problems here for a special reason, because I have a little important thing to say after we get through these two problems. And you're going to hopefully understand where it's going to keep my memory sharp, okay? How we do things that make us remember what we're going to do. But we're going to play a little fractions here. And there's something in common to both of these problems, okay? And you'll see as we work it out and see what happened there. And I'll also explain to you why I needed to have that to remember. So we have 1 1/3 times 3. Now, what do we do when we're multiplying fractions? It's been a while since we've seen many fractions to multiply on this show. So what happens here, and these are for our middle school students, and I'll tell you what, some of our high school students need refreshers on it too. So let's take a look at, and adults out there, some of you are going like, yeah, I sort of remember that. If we were going to look at this is like saying 1 1/3 plus 1 1/3 plus 1 1/3. In other words, write it down 3 times and put an addition between it, okay? And see what you come up with. A shorter way of doing that, because sometimes those numbers aren't so pretty. Now, times 3 is not bad, all right? But if it were times 8, or it was 8.5, then we'd have a whole big messy thing to do. So let's take a look at what happens when we just take the shortcut, is what I like to call it. We're going to make this thing into an improper fraction. So we're going to have a 1 times 3, and we're going to add 1 to the top there. And we're going to get a 4. And we're going to keep that 3. Once again, 1 times 3, get 3. Add 1 more, you get a 4. 4 over 3. Now, 3, put a 1 underneath there, all right? Put a 1 there. And let's let those 3's cancel out. They do a nice job of that, don't they? And we come up with actually a very simple answer. Answer comes out to be, you can be 4 over 1, but let's go ahead and make it the simple lowest terms. Let's go with just 4, all right? That's what we get. So 4 is left over, 4 divided by 1, obviously you get a 4. So I said something in common, so let's figure out what's going on with this other one over here. Now this one's pretty straightforward also. We've got 2 2/5, 1 3/5. We're going to add them together. Now, what do we have to do when we add fractions? We got to have a common denominator. Absolutely common denominator. We've already got one, don't we? We got a 5 and a 5. So that's nice. So what are we going to do? We're going to add the 2 and the 1 here, which is going to give me 3. And now what am I going to do? I'm going to just add numerators. Don't add the 5 and the 5 and get 10. That's not going to fly. That's not going to help us any at all. We're taking 2 fifths and we're adding 3 more fifths to it, which gives us 5 fifths. Now, that's not very simplified, is it? But we can make that easily taken care of because 5 over 5, everybody's out there thinking 1. Absolutely. Add the 1 to the 3, and you know what? That's like saying 3 plus 1, which will give us a 4. So I got 2 4s. That's what's in common, the answer there. And also, it's because it's to remind me today, Connor, 4-year-old who's been watching Mathline now about 2 or 3 years, tuned in today. Hope he's out there. I'm hearing he's supposed to be. And he and his dad and his granddad all have a time where they get together and watch Mathline. I think that's awesome. It was exciting to hear that. So Connor, and to Dad Todd and Grandfather Bob, thanks for tuning in, watching Mathline, and letting us know that that's a great moment there. And what a great way to bond as a family. Hey, watching Mathline. I know some of you say, well, there are other ways we can do that too. There are, but I think that was pretty cool to hear that Connor, Todd, and Bob all together make a nice, 3 generations there with Mathline. I love it. Thanks, you guys, and thanks for letting us know about it. We appreciate you. And again, 4 years old, that was the answer for everybody got that, I guess. Okay, all right. So anyhow, that's what we want to do. Now, let's get to some real business here. Let's get some phones ringing, okay? 844-686-2378. It's a call-in show, and we really want to hear from you guys and ladies and everybody out there who may have a math problem, maybe just want to call in and say, hey, how are you doing? Whatever, at that point. But we do want to hear from you. Let's do some math. Let's get some math going together here. And as we go along here, we're going to listen and hear for hopefully some good questions, good problems, good things coming in from all over the place. And do we have a caller down here? Okay, all right. Let's talk Facebook for a minute because we understand we got a caller trying to get through on the line, so we'll take care of that. By the way, like I said, 844-686-2378. That's where we need to hear from you, okay? Give us that call. It's toll-free. It doesn't cost you anything. Free tutorial help in your math world, all right? And understand we do have a caller, so we'll get Facebook taken care of a little bit later in the show. Welcome to Mathline this afternoon, and who am I talking with?
You're talking with Peyton.
Hey, Peyton, we haven't heard from you in a while. It's good to hear from you today. Glad you're with us, all right? And I believe you're calling from Campbell County, am I right, or something like that? Somewhere up in Upper East Tennessee or Upper Middle Tennessee? Anyway, I'll let you tell me. Where are you calling from?
Calling from Caryville.
Oh, Caryville, all right, which I think that's close to Campbell. It's up there near Cove Lake, I know that. So anyway, enough of the geography lesson. Let's see what kind of math problem you've got for me today. What can I do for you?
All right, so here's what I got. I have 2 x plus 3 in brackets.
Okay, so we got those lovely parentheses, I bet you're talking. That way they are kind of parenthesis things. Okay, so far so good?
Yes.
All right.
Equals. 3.
Okay.
And then 2x minus 9 in brackets.
All right. And is that the end of the problem?
Yes.
Okay. All right. So anything else to add there?
I believe that's all.
Okay. All right. Well, we'll go with what we got there then and see what we're going to pick up here. So parentheses, tell me the big D. Now, I don't mean Dallas, okay? Distributive property we have in math, okay? The distributive property is a big thing, and it means we got to run that 2 through the parentheses. Now, a lot of times people get really nervous when we start putting numbers outside of parentheses. It's simple, folks. It just simply means we're doubling everything inside. That's what this 2 says. If it were 3, we'd triple it. If we were a 7, we would 7 times it, okay? You get the idea. But, Peyton, you're asking me to double. So that one's going to work pretty easily. I let that come out to be 2x, and I think 2 times 3 last time I checked was 6. You still agree with me on that? Am I good?
Yes.
All right. Now, got another side of the problem here. We're going to work through this, okay? And, wow, I'm seeing 6x popping up because that's what 3 times 2, so I'm tripling everything on this side. And then we're going to subtract 27 because that's what happens when you triple 9, 3 times 9. So all of a sudden it looks better, doesn't it? Already looks easier. Not only because I took away all these arrows, but because we don't have the parentheses anymore. So are you with me so far? Are we good?
Yes.
All right, let's roll upon here. So I'm just going to go ahead and subtract 6x from both sides, all right? That's what we want to do. We want to get the x's together. So we're going to subtract 6x, and we're going to say goodbye to those x's right there. That's the whole idea. Now, I'm going to do 2 minus 6. Peyton, that's going to give me a negative 4. Is that okay? We got a negative 4 hopping up here. And those things happen. Negatives happen. And we got a 6. And we got a negative 27. So it looks a little easier every time I scratch my head about that. It looks a little easier, okay, as we move along. Now, we're going to do one more thing. We're going to subtract the 6. Actually, we're going to do a couple more things, but right now we're going to subtract the 6. Because it's got a big plus. Okay, you with me?
Yes. One thing I want to say.
Uh-huh.
I forgot to mention there was an X at the end, but I didn't see it.
Oh, there's an X. Okay. Is it a plus or minus X while we're at it? You're talking about the very beginning of the problem? Don't worry about it. Okay. Well, we come back and rework it if we need to. All right. At this point, I've gotten this far. Hey, they won't let me erase with the pen. It's okay, Peyton. We're cool. We're cool. Don't worry about it. So we will get there. And we have negative 4x. Hey, I just have to do a little, I might go to the calculator for the arithmetic on this one, my friends. Let's see. I get a negative 33. So far, so good. All right. Now, I'm going to tell you. We're going to go ahead and finish it out, okay? I'm not going to try to figure out what would have happened if we had done what we did or gotten better or whatever there. So we got 4x equaling to a negative 33. So let's do a little division. We know it doesn't go evenly. Everybody knows that. But when we divide by 4, it will eventually come out even. It could be a quarter, it could be a half, it could be 3/4, okay? So we're still good on that, all right? So let's see what happens. I'm going to go to the calculator. I want to say 8 1/4. I think was what we're going to have. Let's go ahead and put that in there. We got 8 1/4. And for those of us who love decimals, we will go 8 25/100. There you go. All right. And by the way, it does go positive because we're dividing a negative into a negative. So the final answer for x looks like it's going to be not so bad. Okay. Now, Peyton, you didn't ask me to, but I'm going to tell you, we like to check here on Mathline. All right. You've watched the show, so you know what we do, right? So let's check this thing out. Let's see where this is going to go and see if it's going to take us to something equal in the way we want it at the end. So I'm going to go back to the beginning because that's where we can make an error, okay? And we got 2 times, I'll get right in a minute. How about it? 8 25/100, add 3. And we're going to see on the other side, does that give us 2 times, lots of parentheses going on here, 8 25/100 minus 9. Okay, and I'm going to do it. You said brackets. I like the brackets idea here. Okay, on that side over there, we'll put brackets in. So let's see what happens. First of all, I guess I need to do some addition. So I'm seeing 2 times, it looks like 11 25/100 so far. You see where I got that? Just added 3 to my 8. You with me?
Yeah.
Good. All right, good. On this side, I've got 3 times, and I'm going to see if we can work this thing out in the middle here. 2 times that is going to give us 16 5/10. That was pretty nice. And let's see where we're going to go with that. Minus 9. All right. So, yeah, these are where, folks, we really, when we get decimals like this, or if, heaven forbid, this is really nice that it came out with 25/100. We always like it when they come out nice integral values, but we're going to get through it. We'll make it through. This one looks like we're going to get 22, how about that? Let's do 22 50/100 there, because that's what happens when we double it. On the other side, we got 3 times, how much? Looks like 7 1/2. So the question is, does 3 times 7.5 give me 22.5? Everybody want to know that? Go with calculator. It does. I'm going to tell you it does. It's going to check out fine. So we did all right, Peyton. We worked through that one good. And there we go, 22.5, 22.5. We got it. It checks. It's a good answer. All right. Whew. It's kind of nice. We try to trust ourselves on it, but you know, there's always a chance to make careless mistakes. So that's why we go back and substitute our values into the equation and see what happens there. Does that work for you?
Yeah.
Thank goodness it worked out. We did well. You're good. All right. And good to hear from you again, and glad you're doing all right there. Thank you. That's kind of a challenging problem. Now, folks, follow Peyton's lead and give us a call. All right, 844-686-2378. And while we're waiting for that, I want to go back to yesterday's problem of the day. I do this from time to time, don't I? And it was kind of a crazy problem yesterday. It was a little more difficult than I had anticipated. So let's take a look one more time at this. And I will be honest with you, common denominators are probably not the easiest way to get out of this thing. Using a few benchmark moments, also getting a few BC things. If you look at where we are on it, we have a little bit there of trying to get our numbers in order here, okay? And yesterday we got there, but it took a long time. So let's see, one of our folks, Denise, was good to let us know, that I think there's an easier way. And she said, I changed them into decimals. And I think that's a good idea. This one was simply, and I'm going to go with it here, 7 out of 20. If you think about 7 out of 20, the question is, how can we get to something over 100, all right? And that something over 100, well, multiply by 5. So we got 35, and that gives us 35 hundredths for 7/20. Very good. Now, how about the 2/5? 2/5 works out pretty nicely too. And we got a 100 here, and we got a 40. So that's kind of like 40 hundredths, okay, or 4/10, if you want to write it that way. So already we've covered 2 grounds that I think are a lot easier. Now, 1/3, let's just think about it. You divide 3 into 1, that doesn't go. Add a 0, you got a 3. Oh, it starts repeating, right? So we've got basically a repeating decimal, but we've got 3,300. So we can tell that's smaller than this one. So already we've got 3 of them in order. So the last one is, what do we do? What do we do with this? And by the way, let me go back to this one just a second. Since I was rating them with 100, just like saying 33 and a third over 100. That would be our 1/3 value. So you're seeing, you're also able to work it through percent type things. And then how about 3/8? Woo! Equal to what over 100? That one probably is the one that may take the most to figure out. But it's actually 37.5, which means we have a decimal with 375, which is 375 thousandths. So now it's easy to see. It's easy to see. So Denise, thank you for letting us know on that one. And I think we kind of went there at the end, but getting in the fractions, making it in percents or making it to decimals certainly would be easier. So obviously, 1/3 is the least. Here we go. 7/20 comes in second place. It's moving on up, but still got a ways to go. How about this one? The 375 thousandths, which is like 37.5%. All right. And we continue on moving up to 40% or 4/10 is the case here, or 2/5. All right. So there's your ordering. A lot of times we just have to sit there and kind of play with them and see where they're going to go. Decimals, I think, definitely would be a lot easier point on doing this. So those of you who waded through with me yesterday, hey, thank you for doing that. But now we gave you a little easier way to look at it today. All right. Understand, let's look at Facebook just a little bit here while we're at it. Speaking of which, I mentioned that. Some of you all on Facebook today have been sending us in. Like us, love us, share us at www.facebook.com, and that's a / with Mathline Online. We love it when you check in with us. We like it. We love it also when you give us some answers to our problems and attempt those problems of the day, which are posted every day way in advance, all right? They're actually posted the evening before on the most part, so you got a chance to look at them there. And also, we'll fill you in on what the good old specialized segments, when those pop up, what they're going to be about too. So check us there, like us, love us, and share us. Keep us in your list of contacts, all your friends, and let them know, hey, this is a great show here. Check us out, all right? And last but not least, we have the YouTube, and you can check it there, subscribing to www.youtube.com/Mathline. Had quite a few people who said they really, really did enjoy getting to see our great Halloween special. I thought it was a lot of fun too, folks. I thought it was great fun. Thank you for tuning in. Thanks for giving us some good compliments on that. We probably won't get it. You know, next year Halloween's on a Saturday. We may put it on a Friday night just in case, all right? In case those of you haven't seen it yet. But it was good, a lot of fun doing it. And thank you all for watching it and embracing it for us, all right? And thank you for tuning in. That's my last statement I want to say today. Again, if you haven't voted, get out and vote, all right? And by all means, come back again tomorrow, next time, and we'll see you then.